All right, we're doing the review for the Unit 9 test, Intro to Angles. On question 1, it says the point 1, 1 square root of 3 is on the terminal side of the angle in standard position, and we want to find the value of the other, or the 6 trig functions. So I'm going to kind of sketch what this looks like. So my angle is going to be right here, and so I know that the x value is 1, the y value is the square root of 3, and so from using Pythagorean theorem, 1 squared plus 3 to square root of 3 squared equals c squared. Let's see, that's 1 plus 3, which is 4, and then the square root of 4 is going to be 2. So I know that this hypotenuse is going to be 2. All right, so from there I can do the rest of the trig functions. So sine of this angle is going to be opposite. So this is your angle right here. So opposite over hypotenuse. Cosine is going to be adjacent, which is 1 over hypotenuse. And tangent is going to be opposite over adjacent. So just square root of 3 over 1. And then cosecant is the reciprocal of sine. So 2 over square root of 3. And secant is the reciprocal of cosine, so just 2 over 1. And cotangent is the reciprocal of tangent, so 1 over square root of 3. So these guys here are my answer. All right, we're going to do the same thing on number 2. The point is going to be at 4, 1, so 4, 1. So using Pythagorean theorem, 1 squared plus 4 squared equals c squared. So 1 plus 16 is going to be 17. So we are going to get the square root of 17 for c, which can't be broken down. So we're just going to leave it as the square root of 17. And then we're going to do the 6 trig functions, sine, cosine, tangent, and then cosecant, secant, and cotangent. All right, so once again, your angle is right here. So sine is opposite over hypotenuse. So 1 over square root of 17. Cosine is adjacent over hypotenuse, 4 over the square root of 17. And tangent is opposite over adjacent, so 1 over 4. And then these guys are going to be the reciprocals. So this is just going to be the square root of 17, the square root of 17 over 4, and then just 4 over 1, which is just 4. All right, determine a positive and negative coterminal angle. The whole test is calculator, but you are going to need to leave your answer in terms of pi on some of it. So the 743 is pretty easy. 743, we're going to add 360. That is well, I might even be able to subtract 360 and still get a positive. So either one of these could be positive coterminal angles. So there's lots of answers you could write here. So 383 degrees is a positive coterminal angle. 23 is also a positive coterminal angle. So I'm going to subtract a full revolution again. And there's my -1. So negative 337. So you can subtract or add 360 as many times as you want. All of those angles are going to be coterminal. Looks weird there with the comma. All right, so on this one here, this is in radians. So we're going to subtract or add 2 pi. So in my calculator, I'm going to type -8 over 9. I'm not typing the pi in because I'm just going to leave my answers in terms of pi. And I'm going to add 2. So that is a positive coterminal angle. So 10 pi over 9. All right, so let's go back to the -8 over 9 and let's subtract 2 pi. And that's going to be my negative coterminal angle. So -26 pi over 9. So when you're talking about radians, a full revolution is 2 pi. All right, find all three angles and the missing side of triangle ABC. All right, so the missing side, this one here is the 5, 12, 13 triangle, or you could use Pythagorean theorem. Now to find the missing angles, I'm gonna do sine theta, which is, we're gonna say this guy right here, is opposite over hypotenuse, so 5 over 13. So if I want to try to solve for the angle, I'm going to sine inverse 5 over 13. And whichever mode you are in is going to give you the degree in. So like if I'm in degree mode, which I am right here, I'm in degree mode, I'm going to get my answer in degrees. If you are in radian mode, you're going to get your answer in radians. I think on the test it is going to be in degrees, so let's just hang out in degree mode here. So sine inverse 5 over 13. So angle A, because that's this angle right here, opposite over hypotenuse. Angle A is going to be 22.619. And then if I want to figure out angle B, I can use, really you can use any of the trig ones. If you want to stick with sine, the opposite is now 12. So 12 over 13. Or you could use cosine, or you could add them up and subtract them from 180. I mean, there is just a bajillion options of how you can get that other angle. But I just use sine again. All right, and so the opposite is now 12 if you're finding angle B. And then, of course, angle C is going to be 90 degrees. And don't forget your degree symbol, because if you don't have your degree symbol, then you're saying it's a radian. Oh, and then side C, which is technically a lowercase c, but they're kind of hard to tell the difference. Side C is going to be 13. So don't forget, that's also part of your answer. Okay. All right, so on this one, side C is a little bit harder to figure out. So we're going to Pythagorean theorem. So 7 squared plus 2 squared, and then we're going to end up square rooting it. Maybe I want to leave this in. Yeah. All right, so we're going to leave this as the square root of 53. All right, so that's side C. All right, now for my angles. Now we know angle C is 90 degrees, and just like we did on the other one, to figure out angle A and B, you're going to use one of the trig functions. You don't have to use sine. You could use cosine if you wanted. Cosine is adjacent over hypotenuse. But I'm just going to stick with sine because that's what I like. All right, so if I'm trying to find angle A, this guy right here, opposite is going to be 7 over the square root of 53. So I'm going to sine inverse 7 over the square root of 53, which is going to be 74.054 degrees. And then same thing, but to figure out angle B, the opposite side is now 2. So angle B is going to be 15.945 degrees. All right. Use the calculator to evaluate the following. Make sure you check your mode. So this is just a bunch of calculator work, but make sure you are in the correct mode. So I'm going to do all the degrees first since I'm in degree mode. So that's radians, that's radians. This is degrees. So tangent 630. Ooh, it didn't like that one. I think I probably made that example up. Okay, let's change that example. Let's change that to be 63. That's better. I'll fix that before I make copies. 63 degrees. All right, 1.962. All right, let's see which other one. Secant of 225. So secant is going to be 1 over cosine 225. So that one's going to be negative 1.414. And then I also have secant. Let's change that to be cosecant. Wait, do we have a cosecant? Oh, we do. All right, we're fine. Secant of 310 Oh, I didn't type it in. Cosine. All right, so secant's 1 over cosine, and then 310, which is going to be 1.555. And radians, 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 radians. This is my last degree one. So cosine of 30 plus, and then 42 over 60, because the minutes you would divide by 60. And I would get 0.859. Okay, so now I'm going to change my calculator to be radian mode. So I'm going to go to mode, go down to radians, and I'm going to type everything in again. Just now I'm in radian mode. So sine of 8 pi over 3, 0.866. Cosine of pi over 3, 0.5. Cotangent, which is going to be 1 over tangent, negative 11 pi over 6. .732. Cosecant, which is 1 over sine, 9 pi over 2, which is 1. And then last one, cosine, negative 4 pi over 3, negative 0.5. All right, next page. A 200-foot guy wire is attached to the top of a tower. If the wire makes a 55-degree angle with the ground, how tall is the tower? So I have this tower and I have this wire. And the wire makes a 55-degree angle with the ground, and it is 200 feet. And I want to know how tall the tower is. So I have information about the opposite and the hypotenuse. So that is going to be sine. All right, opposite over hypotenuse. So I know that sine of 55 degrees is going to be x over 200. And so to solve for x, we're just going to times 200 on both sides. And type it in. Once again, make sure you're in the right mode. So I'm going to go back to degree mode. So I'm going to type 200 times sine of 55. And so my tower is 163.83 feet tall, because the wire is in feet. Don't forget your units. All right, the angle of depression from the top of one building to the foot of a building across from the street is 53 degrees. All right, so I got this building here, and I've got this other building here. All right, so the angle of depression. So the angle of depression from the top of one building to, because this is building 1, right? Building. And this is building 2. Okay. Is 53. So this is 53 degrees. The angle of depression to the top of the same building. I feel like I need to use a different color now. All right, so the angle of depression to the top here is 19 degrees. The two buildings are 80 feet apart. What is the height of the shorter building? Okay. Well, let's figure out I think we're gonna have to figure out this side right here. Okay, so if this is 53, this is 53. So I can figure out the height of the tall building by going opposite over adjacent. So that's tangent. So tangent of 53 is going to be the opposite side over the adjacent side, which is 80. And then I'm going to times 80. So 80 times tangent of 53 is going to be 106.16. So this building here is 106.16. Alrighty, now I can kind of make this right triangle right here. And if I can figure out the hypotenuse, I can figure out what this length is. No, because I already know this length. I feel like I'm going to need the hypotenuse. Oh, wait, this is 80. Oh, I'm dumb. Okay, I can figure out this length right here. Because I know from 19 degrees, all right, so looking at the like light pink triangle, that I know the adjacent side and I want to figure out the opposite, this little length right here. So once again, opposite and adjacent, that's going to be tangent. So tangent of 19 degrees. I'm trying to figure out this opposite side over the adjacent side, which is 80. So kind of a similar setup, except now my angle is 19, not 53. So this little side right here, which I'm going to do in this light pink. So this length right here is 27.54. All right, now we're cooking. All right, so I know this whole length from top to bottom is 106, and I know this length right here is 27.54. So if I want to know the height of the shorter building, I just have to subtract those guys. So 106.16 minus 27.54. 106.16 minus 27.54, which is 78.62, and we are in feet. All right. The world record for the fastest spinning on ice skates is 1,848 degrees per second. Describe this rate in revolutions per minute. All right, so I've got 1,848 degrees per 1 second. So first I'm going to change seconds to minutes. So I know that there are 60 seconds in 1 minute. All right, so that takes care of my, my minutes. Now I want to change degrees to be revolutions. So I know that in 1 revolution, there are 360 degrees. That will get rid of my degrees. And now I'm in revolutions per minute. And I just got to type this in. So 1848 times 60 over 360, which is going to be 308 RPMs, revolutions per minute. All right. An old-fashioned record player spins an album at a rate of 33 RPMs. So 33 revolutions per 1 minute. Convert this rate to degrees per second. All right, so in 1 revolution, I've got 360 degrees. So that takes care of my degrees. And then in 1 minute, I have 60 seconds. And then I'm going to type it in. So 33 times 360 and then over 60, which is going to give you 198 degrees per second. Is this the last page? Sweet, it is. Alrighty, suppose a car wheel is 26 inches in diameter. If the tire completes 1 rotation, how far would the car travel? So if you're talking about one rotation, you're talking about circumference. So the circumference is going to be 2 pi r. So 2 pi, 26 is diameter, so that means radius is 13. So we're talking about 26 pi inches, or 81.681 inches. It is a good idea to know how to leave your answer in terms of pi and to get the decimal. You are going to have to do both on the test. If the car is traveling at 60 miles per 1 hour, how fast is the wheel spinning in revolutions per second? All right, so let's first change in 1 hour. There are 60 minutes. And in 1 minute, there are 60 seconds. So I've changed hours to seconds. All right, so now I need to change miles to revolutions. Well, in 1 revolution, there are... Ooh, I need to change miles to inches. Ooh, this is going to be a long one before I can go to revolutions. Okay, so in 1 mile, there's 5... why am I brain recording? Is that right? I feel like it is. Miles to feet. Ah, 5,280. Okay, so in 1 mile, there are 5,280 feet, and in 1 foot, there are 12 inches. Okay. So now that we've changed miles to inches, now we can go from inches to 1 revolution. So in 1 revolution, there are 2 pi times 13 inches. And then that will cancel out the inches. And so my units are going to be, oh, sorry, you can't see that. So my units are going to be revolutions per second. All right, so now we're just going to type all of this in. So everything on top, so 60, you don't really need to type the ones in, times 5280 times 12. And then on bottom, 160, 60, and then 2 times 13. All right, so we can either write this, and the pi is on the bottom here, so 528 over 13 pi, which is the same thing as 12.928 revolutions per second. All right, next one. Given one of the trigonomic functions, find the remaining 5. So this is kind of like the other ones on the front, except it just gives you one of the trig ones. So sine is opposite over hypotenuse. I'm going to draw a little picture here. So if this is my angle, my hypotenuse is going to be 13. The opposite side is going to be 12. This is a 5, 12, 13 triangle. All right, so cosecant is the reciprocal, 13 over 12. Cosine is adjacent over hypotenuse. Secant is the reciprocal of that. And tangent is going to be opposite over adjacent. And there you have it. Let's try another one. All right, so this one's giving me secant. So since cosine is adjacent over hypotenuse, this one is hypotenuse over adjacent, right? Caught another hippie, so just gotta flip it around. I'm gonna draw a little picture again. So the hypotenuse is 5, the adjacent side is the square root of 3. And so when you're trying to figure out the other side, we got a squared plus b squared equals c squared. C squared is the 5, so 25 minus 3. So this other side is going to be the square root of 22, which I don't think you can break down. Nope. All right, so here we go. So I know cosine is going to be the reciprocal of this, square root of 3 over 5. Sine is going to be opposite over hypotenuse. This one will be the reciprocal. Oh, my brain broke for a second. Okay, yep, 5 over square root of 2. And then tangent is going to be opposite over adjacent. So square root of 22 over square root of 3. And you can write that all in one square root, but you don't have to. And then cotangent is going to be the reciprocal, which once again, you could write it all as one giant square root, which really would only be helpful if you could reduce 22 divided by 3. But since we can't, it doesn't really matter. Okay, moving on, almost done. On this one, it says given cosine theta equals 0.2356, find theta. So in our calculator, we are going to inverse 0.2356. And because we want the answer in degrees, make sure you're in degree mode, which is going to be 76.373 degrees. Make sure you put your units and your symbols so you don't get a question wrong for that. All right, this one's going to be the same thing. We're going to inverse, but we're just inversing sine 0.2356. Sine inverse 0.2356, which is going to give you 13.626 degrees. And you can truncate or round. I kind of do, I don't know. It doesn't matter. You can do either one. All right, convert from degrees to radians or radians to degrees. So when you are converting from radians to degrees, you're going to multiply by 180 over pi. A lot of times your pi's are going to end up canceling. So 180 divided by 7 is going to be 25.714 degrees. All right, 26, 420, we're going to multiply that by pi over 180. And then with radians, you don't actually multiply the pi out because a lot of times we leave our answer in terms of pi and a fraction. So 420 divided by 180 is going to be 7 over 3, and then the pi is just going to hang out on top. That's normally how you'll see radians written. All right, degrees, minutes, and seconds. So this is going to be 30 plus 12 over 60 plus 3 over 3,600, which is 60 times 60. And so you can just type all of this in your calculator, or you could do it in pieces. 12 over 60 plus 3 over 3,600. And we are going to want to turn that into a decimal, which is going to be 30.201 degrees. Don't forget your degree symbol. And then last but not least, 15, which doesn't have a pi, doesn't have a degrees. If there's no degree symbol, it is a radian. It just doesn't have pi. All right, so radians don't always have pi. All right, so we're going to multiply this by 180 divided by pi. In this case, we are going to actually have to type the pi in because there is no pi to cancel. So 180 divided by pi. So 15 is going to be 859.3436 degrees. And we are done.